Good morning once more. You're welcome to Amon Math. Today, our question of discussion is from 2018 GCE paper 1 on travel graphs. Okay, the question was reads the diagram below shows the speed time graph of a particle. The particle started off from rest and accelerated uniformly for 10 seconds. It then traveled a constant speed for 20 seconds, then decelerated to the rest. Okay, so the first part says find the speed v the particle reached if its acceleration was 20 meters per second in the first 10 seconds. So remember acceleration is equals to final velocity minus initial over time. Okay, so what is our final velocity? It started at this point, which is our u, and reached there, which is our v. So our final velocity in this case is v that we are looking for, minus our initial where it started, which is at 0. So put a 0 there, over the time it took from here to there, which is 10. Okay, remember we are taught to say our acceleration is 2 meters per second. So I'm going to say, okay, 2 is equal to v minus 0 over 10. So this is over 1, we cross multiply. So how v is equal to 2 times 10, that is 20. So our velocity is 20 meters per second, our speed v. Okay, that is the first one. Let's go to the second part. The second part says, given that the total distance was 750, find the value of t in the diagram. So the total distance is found by calculating the area of the given shape. So when you look at this shape here, this is a trapezium. Or if you want, you can have three shapes: shape 1, shape 2, shape 3, where we have a triangle, a square there, and another triangle. So we are going just to use the trapezium formula, which is a is equals to half a plus b times our h. So a stands for the area, which is 750, is equal to our half. Our a is this distance from here to here. That is our a, so meaning 30 minus 10, which is 20, plus our b is from there to there, which is t. Then height is from here coming down, which is our 20 there, that which we have found already there. So we have 7/5 being equal to, I'll say the half of this 20 outside, that is 10. Then I have 20 plus a t there. Okay, so we have 7/5 being equal to, open brackets, that is 200 plus 10t. So we group the like terms. We are going to have 10t being equal to 750 minus, when this goes the other side, becomes minus 200. So our 10t will be equal to 550. So over 10 over 10. So our t therefore equals to 55. Okay, what is the answer for our B? Now coming to C, what is the speed What was the speed at 40 seconds? What was the speed at 40 seconds? Okay, let's have a bit clear look at it very well so that we are able to see what we mean. 40 seconds at 40 seconds. So we have 30 here, we found that this is 55. So meaning 40, roughly you can say, let's say 40 is here. So we are looking for the speed here at 40 seconds, which is our V. So the first thing that we need to know is that here, remember it was decelerating. So the deceleration from here to here is the same from this point to here, or the deceleration at that line is the same. In short, we are talking of the gradient. The gradient of this slant line is the same from that point to this point. So meaning we can use this same information of deceleration in order to get our value there. Okay. So the first thing that we're going to do is to calculate the value of deceleration. So we're going to say A is equals to V minus U over T. Okay, our initial velocity is this one, and our final at rest is this one. So meaning we are going to have 0 because this is where it rested, which is the final velocity. Started at that point and ended here. Please don't say 55 because 55, this is time, but we're looking at speed, minus our initial where it started, it is at 20 over, so we are looking at from 30 to 55, which is 25, the difference between the two. Okay, so we have negative 20 over 25. When we reduce this one, we are going to have 5 into 20, that is negative 4. 5 into 25, that is 5. Okay, so that is our A. Now the question says the speed at 40. So I'm going to say, okay, fine. Our V therefore will be equal to U plus AT. Final velocity is equal to initial velocity plus acceleration or deceleration times time. Okay, so this will be equal to our initial. Now, since we are looking at 40, our initial velocity is this same one there, which is 20, plus our deceleration is negative 4 over 5 multiplied by, we are looking at this point to this point, from that point to this point, meaning from 30 to 40, which gives us a 10. Okay, so we are going to have 20 minus positive, negative, that's minus 4 times 10, that is 40, divided by 5, that is 8. So 20 minus 8, that automatically gives us 12 meters per second as our V. So this is how we could have solved this type of the travel graph question. Thank you so much for listening.